Okay, so first of all, let's graph it. So 4, -2. So we're going to go over to 4, 1, 2, 3, 4, down to -2. And this is going to be our terminal side. And we're going to make a little triangle. And this is going to be theta. So theta is always the angle between the terminal side and the x-axis. So again, you guys, make sure you know that theta, that's like your reference angle, is always going to be between the terminal side and the x-axis. So what is the length of this side right here? 4. So the length of this side is 4. What is the length of this side? 2. Remember, this is your x and this is your y. And now, what do we need to find? Hypotenuse. So how do we find the hypotenuse? Okay. So a squared plus b squared equals c squared. And in this case, you guys, they usually call this r when you're doing trig. So a squared is going to be 2. B squared is going to be 4. And we're looking for that c squared. So 2 squared is 4. 4 squared is, so 4 plus 16 is 20. To get rid of that, we're going to take the square root of 20 from both sides. You guys, but we're not going to leave it. We're going to see if we can simplify the square root of 20, and can we? So it becomes 2 square roots of 5 equals c. Now, what we're going to do is we're going to find all 6 trig measures. When we go to write them, make sure you're always writing the trig measure and the theta. So we're going to start with sine of theta. And again, you guys, theta is always between the terminal side and the x-axis. So here is theta. That's that angle measure you're looking for. What is sine? What is the ratio of sine? Say it one more time. 2 over 2 square roots of 5. And then let's do cosecant because they go together. And what is cosecant of theta? 2 square roots of 5 over 2. Okay, there's a couple adjustments that we need to do before we're going to move on to our other ones. What do you notice about the sine of theta? What adjustment do I need to make? Right, we need to get that square root of 5 out of the denominator. How do we do that? You can multiply by 2 square roots of 5, but we can just leave that 2 there and just get rid of the square root of 5. Since it's all multiplication, we can do that. Okay. So there's something else we can do. So we're going to try to do it all at once. I multiplied the top and the bottom by the square root of 5 so I can get the square root out of the denominator. But I can also reduce these 2's. 2 goes in the 2 once, 2 goes in the 2 once. Okay, so what is 1 times the square root of 5? It is the square root of 5. What is the square root of 5 times the square root of 5? The square root of, well, what's 5 times 5? So it's the square root of 25. And what is the square root of 25? 5. Now, the last adjustment is sine positive or negative in the 4th quadrant? All students take calculus. So C is cosine and secant, so this is going to be negative, so I need to make it a negative. Because in the 4th quadrant, sine is always negative. That's why the quadrants right up there, all students take calculus. So in the 1st quadrant, all the trig functions are positive. in this quadrant, sine is positive. In this quadrant, tangent is positive. In this quadrant, cosine is positive. And that's because our x value is positive. Over here, it's because our y value is positive.
That makes sense.
Okay, now what do I need to do here? Cancel out the 2's, and what am I left with? Okay, and when we do that, is cosecant positive or negative? Negative. If sine is negative, then cosecant is negative. Okay, we're going to use that. We're going to use that picture again. Now we're going to find cosine of theta. What is cosine of theta? Cosine is the adjacent over the hypotenuse. So what's the adjacent side of theta? 4. What is the hypotenuse? And then let's find secant of theta since those go together. So what would the secant of theta be?
2 lose 5 from 4.
Okay. When I look at these, I see a couple things, right? I can't have a square root, and I need to reduce them. And then I need to look at the signs. So those are the 3 things that when I say adjustments, you need to look for. Does it need to be negative? Is there a square root in the denominator? Is there a radical in the denominator? And does the fraction need to be reduced? Those 3 things have to happen. Okay, so what here do we need to take care of? We need to take care of the square root of 5, and we also need to reduce the fraction. 2 goes in the 2 once, 2 goes in the 4 2 times. Now let's multiply straight across. 2 times the square root of 5 is, and the square root of 5 times the square root of 5? And do I need to make this negative? Is cosine positive or negative in the 4th quadrant?
Positive.
Positive, so we're done with that one. And what do I need to do to secant? Do I need to get is there a square root in the denominator? No. So that's good. What did you say? I need to reduce the 2 and the 4. 2 goes in the 2 once, 2 goes in the 4. And then I'm left with the square root of 5 over 2. Now remember, cosine and secant are positive in the 4th quadrant, so we're done with those. And now all we have left is tangent and cotangent. Okay, so looking at theta, what is tangent? The opposite over adjacent, so 2 over 4. And then cotangent would be,
4 over 2.
because they're reciprocals of each other. Now, do I have to get rid of any radicals?
No.
Nope, so we're good there. Do I need to reduce any fractions?
Yes.
Yes. Okay, so 2 goes into 2 once, 2 goes in the 4 twice, and I'm left with 1/2. Now, is tangent positive or negative in the 4th quadrant? Negative, so I'm going to make this negative. And then what would cotangent end up being? -2. You guys, the nice thing is that if tangent is negative, that means cotangent has to be negative. So their reciprocals always match. And then that is your final answer. So when it says the terminal side is listed or it contains this ordered pair, this is what you're going to do. And then it says find the exact measure. This is what you're going to do to it. What questions do you have?